What's up, mindsetters? It is a Tuesday afternoon. 4 o'clock is your time and you're hanging out with Looney and Phil. Phil, how are you doing?
I'm great, thanks, and you, Looney?
I'm good, thank you. What are we doing for the grade 10 today?
Well, grade 10s, I'm going to be discussing a section that a lot of you kind of seem to battle with, but guys, relax, get a pen and paper, get our notes online. Looney, I'm sure you're going to post them. And we're going to be dealing with motion today.
Okay, cool. Mindsetters, you heard it, we're doing motion. It was one of my favorite topics in physical sciences back in the day, like couple of years ago when I was in grade 10. So make sure you hit us up on Facebook, on facebook.com/learnextra. Don't forget to chat to us and follow us on Twitter @learnextra. You can download the show notes, the videos, the schedules, and check out what we have to offer on learnextra.co.za/live. So with all that said, I'll hand it over back to Phil.
Thanks so much, Looney. Okay, well, today we are talking about motion, guys. Motion is one of my favorites, and just before we swapped over, we were talking about cars and moving around. Now, motion itself is one of the things that I love doing with my body. I like to move myself around. Now, for some reason, science has found different ways to describe motion, and this has confused a lot of the grade 10s. So what we're going to do today is we're going to concentrate on the language today. We're going to introduce some new words, make you feel a little bit better about some of the words that we deal with in terms of motion and things which are moving around. Now, this is going to be part 1 of 3-lesson series where we're going to be taking a look at displacement, velocity, acceleration, all these new words. Don't panic, guys. Get on the website, get our notes, because I do explain inside our notes what all these words mean. And the best way to explain these is we're actually going to do some examples with them. And I've got something really cool to show you a little bit later on, and I want you guys to log onto our website and actually do the experiment with us. Grab a ruler and a protractor. You're going to need one, especially if you've downloaded those notes, and we can play around together, guys. Okay, all right, so now let's see what's on the menu for today. Now, if you were watching last week, we introduced some new words. We're going to talk about some vector quantities. Now, guys, if you were listening last week, vector quantities, right, we're going to be dealing with them. Remember that they had 2 parts to them. So I'm hoping that you're starting to revise them back at home and you're starting to say, okay, I know exactly what a vector quantity is, Phil. Okay, then what we're going to do is we're going to explore and understand. Now, this is going to be one of the most interesting things, because I'm going to show you some things which maybe you might not have thought of before. We're going to talk about this word displacement. You might have heard of it before. And then distance. Most of you have heard about distance and you've worked with it inside maths. So displacement and distance, I'm going to tell you about the difference between the two. Some people have the impression that distance is just like something that you've got to change it into displacement. They're actually slightly different concepts. So let's take a little bit of a slowdown today, excuse the pun, and we're going to deal with distance and displacement together. And I'm going to tell you the difference between the two. And then, this is one of the most commonly confused things as well, is we're going to tell the difference between velocity and speed. Okay, now a lot of people are saying, nah, they're just the same thing, one's got direction, the other one doesn't. Guys, no, what I'm going to do is we're going to use an example, and I love this example because we're actually going to be dealing with our studios here in Randburg, and we're going to be playing around with a map, and you guys get to interact with a map online. Okay, there's a little bit of a slip there. All right, you're going to be dealing with Google Maps today. And we're going to try and see if we can't use maps to find out the difference between distance and displacement, between velocity and speed, and we're going to try and separate the two. But before we get too far ahead of ourselves, I think we should just take a step backwards to last week's lesson and start to revise what we were talking about. Okay, now we need to remind ourselves what a vector quantity is. Now, last week I told you that vector was also an evil character in a cartoon. Guys, that's not the sort of vector I'm talking about. A vector is something which has got magnitude and direction. Now you say, okay, well, Phil, please remind me again, what is magnitude? Magnitude is how much you have of something. So I would like my bank account or my payslip to have a very large magnitude. That means that the number is large. So anytime you talk about a magnitude is how much you have of something. So if somebody has a large magnitude of anything, they have a lot of that thing that they've got. It doesn't matter what you've got, but a magnitude just means how much I have. Now, this might seem a little bit confusing until we start drawing on a map later on today. And this is the most important thing. Guys, vectors have got direction. Now, it's very important. The example which I used in the last lesson is I said, okay, well, stand up and walk 5 meters. What I've described to you is a quantity which was 5. I gave it a unit of meters, but I didn't tell you where to walk 5 meters. So if you stood up turned around to your couch and you tried to walk 5 meters, you wouldn't be able to walk over a couch. Now you can, but please don't. Okay, your mom's going to get upset with you. Okay, but now direction is very, very important, guys. If you were to tell me that the direction should be, well, stand up, walk 5 meters towards the kitchen, not a problem. You would know exactly where to go and how far to go. What I've given you then is a vector quantity. Okay, so the magnitude, again, is how much we have. Now, this is where things get really interesting. Now, we're going to start dealing with some of these words, and I'm going to introduce them, and then we're going to try and see what they mean. So here's some of the new words. Displacement. Now, this is a bit of a weird word. We've dealt with displacement before. Displacement you might have dealt with in grade 7 when you were talking about density. Displacement, when you dipped something in water and the water leaped out. Guys, if you want to take a look around, Archimedes was the guy. That was the guy that shouted out Eureka and ran down the street naked. Okay, now what this guy managed to figure out was that if he gets into the bath, the water goes somewhere else. Displacement means moving away from the original position. So now displacement is a change in position, specifically in a certain direction. So it's quite important that you attach a direction to displacement. So I say, okay, well, what did I do? Okay, well, Phil told me out of the TV, I listened to the TV, and I got up and I moved 5 meters. And he told me exactly where to go, towards the kitchen. That's where all the good stuff is. Okay, now this word velocity. Velocity is something that I really want to explore with you today. Now, it's the rate of change of displacement. Now, you might say, hey, Phil, whoa, hang on just a second. Now, let's just rephrase this in a way that I might understand a little bit better. So I said to you, your displacement is your movement in a particular direction, or it's your change in position in a particular direction. So I said, well, how far did you move? Well, I moved 5 meters. In which direction? Oh, okay, towards the kitchen. Now, velocity tells me how quickly I got that done. Now, if it's late in the afternoon and you've been watching Mindset, Learn Extra all evening, you're nice and hungry from all that thinking. Guys, your brain uses up 1/4 of your energy. So after all that energy, you're like, oh, I'm hungry. And then your mom says, no, dinner's ready. What's going to happen here? Your velocity will be very large. You will get that 5 meters very, very quickly. It's how quickly you change your position. That is velocity. Now, it's going to become quite clear that velocity sounds a lot like speed. You might say, okay, well, I went there fast. Fast means high velocity or high speed. There is a slight difference between the two. Okay, now, one of the things that I want you to be aware of as we go through the show today is if you use a quantity like displacement to calculate velocity. So I've used displacement to describe velocity. That second quantity also becomes a vector. So I said displacement is a vector. It's got a magnitude and a direction. So everyone's okay with that? I've got displacement, it's a vector. Now velocity uses displacement. If one quantity uses another that is a vector, the second one also becomes a vector itself. So velocity has also got a direction attached to it. And that's one of the major differences. Okay, now the best way to do this is I'm going to introduce you to a little bit of an example here. Okay, now we're going to start taking a look at the difference between distance and displacement. Now when I talk about distance, I say on a Tuesday afternoon, my job is to come here and teach you guys, and I love my job. And one of the things that I can measure out in my car is I measure out, it takes me 27 kilometers to drive here. Now that is my distance. So it's the total path which I've taken. Now, most of you guys know exactly what I'm talking about distance. If I walk 5 meters this way, then walk 2 meters in another direction, then walk 2 meters back, you just start adding them up. So 5 plus 2 plus 2. Okay, now that means that I've got 9 meters of distance. All you do is you add up the small pieces in between there, and that will give you your total distance. So distance is probably the simplest thing as well. And if you've done earth sciences and you've started dealing with geography, most of you have traced out the distances on a map using a string. Now, exactly the same thing is going to be talked out here, and we are going to use a map because motion is all about moving from one place to another. And I'm going to show you on this map how to move to one of my favorite places, and that's right here in our Ramberg studios. Now, guys, you can actually follow it through on the website, and you can go to maps.google.co.za. And we're going to be dealing with one of these particular maps. And the really cool thing about that Google map is you can actually see what our building looks like from the outside. It's really, really fun. I think the Google car drove past and we were doing some gardening and we were fixing up the pavement, making it look all nice. Really, really cool, and we can actually see what the studios look like. So you guys get to see what the the Mindset studios actually look like over here. So Mindset and Traffic are inside this building, and here we go. This is the outside of our building, and one of the really cool things that you can do on Google Maps, and there it is, it's maps.google.co.za, and what happens on here is you can actually pan around, you can actually take a look. This is kind of cool. All that you have to do is click on a different position, and you can see where our building is. Now, our building is on, I'm going to flash on that address as well for you. It's Pretoria Avenue in Randburg in Gauteng. So on Pretoria Avenue, and I'm going to zoom around, and there's our neighbors, and you can actually look back at some of the people outside there. So you've got some cars which are coming out of our studios over there. I'm going to walk down the street with you, and you can actually see what's going on here. So now I'm going to move in a virtual way along the pavement outside our building. Okay, so what happens over here, if I move a little bit forward, I can start to take a look at the outside of our building, and that's particularly cool. This is one of the things that Google actually allows us to do. So now if I take a look back on our buildings, you can actually see what's going on in these buildings. There we go, and I'm actually looking up at the very studios which this broadcast is coming from now. So inside these studios, we've got these beautiful Mindset studios, and this is how we bring these pictures to you. It's all inside that building. Now what I'm going to do is I'm going to use this map over here. So maps.google.co.za. I'm going to ask Looney to post the address so you can actually find the same picture as us. Okay, it's on Pretoria Avenue in Randburg in Gauteng. Now, what I'm going to do is I'm going to zoom out a little bit. I know it's really nice to look at the buildings, but I want to see what this looks like on a map. So I'm going to take a look and see where the street corner is. How do I get to the Mindset studios and do all these really amazing things? So let's go back out there. Let's zoom right out. And let's take a look at the exact address. Now, this is how you're going to find it. It's on the corner of Dover and Pretoria Street. So I'm going to leave that on the map there for you. Now, if you zoom in really carefully, you can actually see the roof of our building. It's covered in this nice silver stuff to keep off the heat. And if you look really closely on the corner of our building, you can actually see the satellite dish. Now, this is one of the ways that we communicate. We send out the signal, the wonderful news of Mindset, and we spread this out using this wonderful satellite dish. Okay, so now on the corner of Dover and Pretoria Street, we've got our studios. But how do I get there? Now, I'm going to zoom out a little bit, and I'm going to show you where we're going to start our journey. Then, I'm going to go back to a map, and you guys are going to actually help me out. Now, there's something which I want to pay attention to. Now, in the bottom left corner of a screen, if you're looking at maps.google.co.za, you'll actually see a scale. That'll tell me a way to look for the size of what I'm looking for. I can actually measure out, I can actually predict how far away I am from Mindset Studios. Now, some of you guys might be very far away. I know that some of you are watching us from even other countries. So I want to make sure that I can actually pick out the distances when I'm looking at a map like this. To do that, I use a scale down at the bottom here. So I'm going to zoom out a little bit, and I'm going to tell you where we're going to start our journey today. Okay, so now I don't start at the corner of Dover and Pretoria Street. I'm going to start my journey way up here on the other side of these two blocks at the corner of Kent and Bond Street. Now, this is one of the places that I drive from, so I usually come down Bond Street and I turn around here. And what happens if I wanted to start at the corner of Kent and Bond Street? So that's position A. Then I want to make my way back down here to Mindset Studios. Now, there's a couple of ways that you can do this. I can zoom out to make sure that I've got the entire map on one screen, and this is exactly the map which I'm going to be using. Guys, I want you to start calculating how far you would have to go from the corner of Kent and Bond all the way down to the corner of Pretoria and Dover Street. I want you guys to try that out because I think it's almost time for an ad break, and I want to give you guys a little bit of a chance to try and figure this out. Then maybe you guys can work with us as well. Guys, get a ruler. We're going to be working with a ruler and a calculator, making sure that we can scale things up and scale things down. I think it's time for an ad break, Lenny.
Okay, cool. Mindset is I did post the maps.google.co.za on our Facebook page, so make sure you go on to facebook.com/learnextra and check that out, and make sure you have all your rulers and everything else that Phil said you need to have, and we'll see you straight after the break. Welcome back, Mindsetters, from a very short break. Just a quick shout out to Twanelo Motaung, Apiwe Mtembu, and Apiwe Maketini. Thank you so much, guys, for tuning in and for being such awesome Mindsetters. I hope you guys are really enjoying the show, and we're going to continue in a few seconds. Just to tell you that Mindset needs you. So we need you to tell your teachers, to tell everyone that you know who is got anything to do with grade 10 to 12 CAPS aligned programming. So we want video presentation people, reviewers, and presentations. Let me see. Yes. So please, guys, just make sure you tell your teachers that they should apply before the 26th of August, 2013. All they need to do is go on to mindset.co.za/application, apply. Yes. Sorry. Mindset.co.za/learn/jobs. So if you tell your teachers to just go and apply, guys, we really need them. Grade 10 to 12 CAPS aligned recruitment drive that we're having here in Mindset. Phil, over to you.
Well, what I've done is I've taken a small slice of that map, which we saw, and this is our local Randburg area. I asked you guys to start working out with the distance. Now I want to show you how exactly to do this using our Google Maps. All right, so over here, I've got a ruler ready. I hope you guys have also got a ruler. So this ruler I can move around on my map. All right, so there we go. I think, hold on, we're having a little bit of a problem there with the ruler. But what I'm going to ask you to do is I want you to work with us. And what we're going to do is we're actually going to measure out the path. Now, I've chosen two particular places around here in the surrounding blocks. And we're actually going to measure them out together. So what I'm going to ask you to do is to get from point A to point B. So now, guys, I want to make sure that you can work with your rulers and actually work with the maps, and we can actually see what goes on here. Okay, now, I said I want to go from point A to point B. Now, unless you're a bird or you've got your own helicopter, you guys cannot fly over a block. Okay, now the reason I point out those two examples is because I'm actually going to use that in a moment. So what I'm going to do is I'm now going to plot out a path to get from point A to point B. Now, there's a few ways we can do this. So what I'm going to do is I'm going to draw out the two pieces, the two parts. So I'm going to start out, there's my first leg of my journey. I travel first down Main Avenue to get to that corner. Then the most direct way to get to these corners, and this is just down the street from us, is I can plot out a second part to my journey, which is all the way over there. So what I'm actually going to do is now I can start to measure out the parts of my journey. So the way that you can start to do that, and I'm actually going to bring up another ruler here. It's, there we go. All right, now I want you to grab that ruler that I told you to get out. So here we go, I've got my ruler ready. So now what I'm going to do is I'm going to use my ruler to scale out my map. Now, the way that you do this is you start to line up your ruler the same way that I'm doing this, and we're going to start to measure out the path on here. Now you might notice I've actually got the wrong part of the ruler there. You'll notice that some rulers are measuring in inches and you're going to be measuring in centimeters. Oh, it's horrible, confusing. Make sure that you're using the correct side of your ruler. Now this ruler can measure both millimeters and inches. Guys, we want millimeters. Okay, so now what I'm going to do is I'm going to measure out that first part, that first leg. Later on, I'll be calling this a component. Guys, if you remember from last week when I started adding together vectors, I started to call them components. So let's measure out our first leg. Let's measure out the first part of our journey. Okay, so now what I'm going to do is I'm going to say, okay, well, I'm going to put the 0 on my starting point, which is A. I see that I move 85 millimeters along this map. All right, so now the question is, how do we actually start to deal with that in terms of scale? Now, I'm going to practice with the scale. And we're going to try and change 85 millimeters into an actual distance. Now, I said that my scale, and I'd measured this a little bit earlier on, I found that on my map was that every 25 millimeters represented, and sorry, that's actually a mistake there, that's 100 meters. That's not 100 millimeters. Okay, so now my scale is 25 millimeters on my map to 100 meters in real life. It wouldn't be 100 millimeters or we'd never get anywhere. Okay, so there we go. So 25 millimeters on my map represents 100 meters in real life. Now, how do I scale 25 into 85? And you say, oh, this is a little bit difficult. So what do I do? Okay, now I've got my scale here. Let's write down my scale together. Now, there's a certain way of laying out your scale which actually makes life a lot easier. So 25 millimeters has a ratio to 100 meters. Now, you lay out your scale that way. Now let's put in the numbers that we'd like to scale. So which one do I have? Do I have the map size or do I have the real size? I have the map size. So what I'm going to do is I'm going to put map underneath map, and then I'm going to put real underneath real. Okay, now I'm going to show you how to work with these ratios, because a lot of grade 10s really struggle with ratios and when they deal with the vector diagrams. So let's write in a different color to show you the new information. I measured out on my map that I moved 85 millimeters. So that's what the ruler told me. I would like to know what is the real distance that I moved. Okay, well, the question is how to actually work with these. Now, here's one of the clues. Anytime you've got two of the same, now there's a way to move around here. I want to move from here, around here, and end up here. Now, if you have two of the same, I want to get rid of the millimeters. I want to make sure that they cancel out. The only way to do that is to divide. If you're going up or down, you divide. So here goes my sum. So I start out with 85. I divide by 25, and that gets rid of the millimeters, because the millimeters will cancel out. So I divide by the thing which I have. Then I multiply by the thing which I want. So you multiply to go across here. So I divide to go up, and you multiply to go across. So you multiply by 100. And let's put that into the calculator, and let's see what comes out here. So I grab my wonderful Casio calculator, and I say, all right, I'm going to start out with 85. And then what I'm going to do is I'm going to divide by 25. So there's my answer, and then I multiply that by 100. And that will get me an answer now in meters. So that is 340 meters. That was the length of my first trip. Okay, so that tells me that I moved 340 meters. Let's mark that on the map, because last week I told you that you should write onto your map the real distances. So that was 340 meters, the first part of my journey. But I went further. I turned left once I reached there. So what I'm going to do now is I'm going to move my ruler, and we're going to measure the second part of this. So we actually need to change where we're going there. There we go. We can actually flip this right around. Let's make sure that our 0 is on the next part. Okay, so guys, your ruler is a little bit easier to move around than mine, but there we go. There we go. That's what we're looking for. All right. So if I measure from 0 over there, I measure another 140 millimeters. So I hope that you can measure exactly the same thing. So 140 millimeters. Guys, this map is in the notes. They're free. They're on the website. So now 140 millimeters over there. Okay, now we're going to change 140 millimeters, and we're going to see if you guys can do the scaling yourself. So I want to change 140 millimeters. So I start out with 140 millimeters. There's my two ratios. Remember that you write them together. So 25 millimeters changes to 100 meters in real life. So there's my map sizes. There's my real sizes. Now remember that moving up and down is divide. So you take 140, divide by 25, multiply by 100, and that should get us to our answer. So you divide there, and to move across, you multiply. That's always the rule for your ratio. It's a really nice, easy way to do this. Okay, so now let's do exactly that. So I take 140, I divide by the thing which I have to get rid of it in terms of millimeters. I don't want millimeters, I want the meters in real life. Then I'm going to multiply by 100. And that lands up being, so let's take a look at what we've got here. Let's clear. So 140 divided by 25, and that gets us an answer of 28 over 5, multiply by 100, and that'll get us our real life distance of 560 meters. Okay, so that means that I moved another 560 meters. Okay, so let's write that in on my map. Let's make sure that we've got there. So 560 meters. Okay, now it's fairly easy to figure out what our distance was that was covered. All I would need to do is to add up 340 meters, which I traveled in a certain direction, and then 560 meters in another direction. So that's quite easy. My distance, which I traveled, and I emphasize that word, our distance is a combination of those two. My distance was equal to 340 meters down the one street, plus 560 meters, which we found down the next street when we turned left. And if you take a look at that, we moved a total of 900 meters. Now guys, I want you to take a look at this quantity which I've written down. is this a scalar quantity or is this a vector quantity, and how can you tell? Now, all I can see is 900 meters. If I told you one day I walked 900 meters. Okay, well, it's very good for my legs, but it doesn't tell me where I landed up. So distance is not very useful for telling us exactly where we moved to. I want to know precisely what I managed to achieve. Now, here's the thing which I want to impress upon you. Now, displacement is something slightly different. What I want to do is I want to draw in something called displacement. Now, displacement is the change in position from our starting point to our finish point directly. Very often it's described as the crow flies. Now, what that means is if you were a crow, you would be able to fly directly from point A to point B. You wouldn't have to stick to all the streets. This is the path that you would take. Now, this is the end achievement of what I've done there. So what I'm trying to say here is that displacement only cares about what I achieved, not how I got there. So this is my displacement. Displacement is a direct measurement from my beginning point to my end point. And I'm going to show you how to do this using a ruler. We can actually figure out what the displacement is, but then we've got to grab a protractor to figure out the direction. And that's an excellent time to start dealing with how to measure direction. So guys, I hope that you're actually doing this on your printed out maps at home, or you're doing this on a screen and you can actually figure out the scale. Now you might notice in the notes that I didn't actually give you a scale like 25 millimeters to 100 meters, because your printers and your screens will all be different sizes. But I left a small key over here for 100 meters over here. So let me just highlight what I'm saying over here. There's 100 meters over there, and that tells me that from that position to that position is 100 meters on your particular map. Guys, you can do this. You can play around with your own scales. See if you come out to the same distance using the map. You should come out to 900 meters distance. Now let's deal with the displacement. Okay, so I'm going to grab my trusty ruler, and we are now going to measure the displacement from the starting point, which was position A, to the end point, which was B. Okay, so now let's see if our ruler is long enough. I'm hoping it is. It might just be. There we go, starting at 0, and then twisting around. Let's actually lengthen it. I'm very, very lucky that this ruler can play around. Okay, but I've got a starting position over here. So there we go, starting at 0. We're almost there. All right, so from 0, oh, we're almost inside there. I think we're 5 millimeters short. Let's just make sure that that lines up very nicely. So that's 0 to 150. And then from that position, I can measure that there is another 5 millimeters. So I've got 155 millimeters on here. So what I'm going to do now is I'm going to figure out how far 155 millimeters is. Now that's not my distance at all. That's the difference in position from A to B. But that's not all. That is not a true displacement. So we're going to have to add something to my displacement, which is going to confuse some people. But I'm going to do this nice and slowly, so you don't need to worry. My displacement on my map, what was the size? It was 155 millimeters. Now I want to know what that was in real life. Let's scale it up. Let's try and find out what the real life distance was, or displacement rather was. So now remember what I said? You divide by 25 millimeters to get rid of the millimeters, the thing that you have. You multiply by the thing which you want, and that was in meters. And what do we get? So let's do this all together. So I say 155 millimeters divided by 25 millimeters, and that gave me an answer there, 31 over 5. Then I multiply by 100. There we go, and I get an answer of 620 meters. So that is my displacement. But it's only the magnitude, guys. There's something missing from this. I want you to figure out what it is. I've only given you how far it was directly from point A to point B. So if you were a bird, if you were a crow, if you were any other sort of bird, if you could fly directly from point A to point B, you would only need to travel 620 meters. This is the distance as the crow flies. But now there's something missing. This is not a real displacement yet. So what I want to do is I want to make displacement into a vector. I've given you the magnitude. Now guys, I want you to figure out the direction. Okay, now that's going to get a little bit more complicated. So this red line which I've drawn on my screen now represents my displacement. I know that my displacement is 620 meters big. Is that correct? Let's just check my value there. So, yeah, absolutely 620 meters, and I'm being very good about it. I'm writing it in 620 meters over there. Now, the thing that I need to add to displacement is direction. Now, what I'm going to ask you to do, if you're doing this at home, is I want you to give me direction in terms of bearing. So, on this particular map, what I can do is I can indicate which direction is north. I'm actually going to indicate that very nicely over here. North is upwards on this map. So if we've got an upwards arrow for north, and I'm actually going to draw in another line directly from my starting point, that's actually going to help me out very nicely. So north is a vertical line. That is where I find north. So now to measure out my displacement, I need to measure out both its size, its magnitude, and its direction. So guys, I'm going to give you a little bit of time to figure that out, measure it out, and any one of you, maybe post on the page even. Start to suggest to us your problems and see if you can figure out how to work with bearing with this particular problem. If you're getting a bearing of more than 90, it looks like you're on the right path. I want you to play around with these notes, guys. But I think it's time for a break so these guys can work it on their own.
Okay. Mindset is let's take a very quick break and we'll be back straight after this. Welcome back, Mindsetters. Like I said before the break, if you know anyone who's interested in doing grade 10 to 12 CAPS, content development, review, and video presentation, please urge them, if you know any of your teachers or your parents, please urge them to go apply on mindset.co.za/learn/jobs. I will post all the information on our Facebook page, and applications do close on the 26th of August. This is like now, 6 days from now. So please make sure you ask them and you urge them to go apply on our website. And yes, guys, Phil, back to you.
Thanks so much, Luni. Okay, now before the break, I gave you guys a little bit of a challenge. I wanted to know how to deal with displacement. Now, I figured out that displacement was the path taken from the beginning to the end of a movement in a particular direction. So from point A to point B in the shortest possible path. Sometimes it's described as the crow flies. Okay, now there's not that many crows where we stay, but any bird which travels directly doesn't need to follow the roads, doesn't need to do 900 meters of distance. Now, displacement we managed to figure out off our map when we were scaling it. We managed to figure out that displacement over here was just over 600 meters. Now, this is not the most accurate way of doing things. Construction is always due to errors. Now, if we get a little bit of time, I'm going to come back to this and I'm going to show you a little bit of inaccuracy in here. But now, before we move on today, I wanted to show you guys how to deal with bearing. We had a lot of questions last time when we were talking about, Phil, how do I do is bearing the same as north, east, south, west, or what am I doing? Now, guys, I'm going to show you how to find the bearing using your protractor. So if I draw a line which is in line with north, now you've got to know where north is on your map. Then, here's the trick. You take your protractor and you move it, that really nice little magnifying glass, that really nice little centerpiece, you put that on where you started. Now, I want to pay attention to the top of my protractor. Make sure that your top of your protractor, and you can't really see this very nicely, I'm going to write it in here. You should have a protractor over there that has 0 in that position. So your 0 should be lined up with north. Because here's your definition for bearing. I start from north at 0 degrees. That is a bearing of 0. I rotate to my particular displacement or any vector. I rotate clockwise. So it's clockwise for you guys. So I rotate until I reach my displacement. I'm going to show you what that looks like on my diagram. So I start from 0 up at the top here. There's 0 degrees. I rotate on my diagram, and here it is. I rotate from 0, and I start to go all the way around here. So let's actually try to see if I can't draw all the way around here. Here we go. I rotate, I rotate, I rotate, and I try to find that angle over there. So what I'm going to do here is I'm going to find out what that angle is over there where I've ended. So let's make sure that we can actually draw this in. So that angle over there, I'm going to find that out to be, if I line this up properly, I can see my protractor's moved a little bit. My protractor lines up with around about 130 degrees. So I start on one side, which is north at 0, and I rotate clockwise all the way around until I meet my particular vector. Could be distance, could be displacement, whatever might be the case. If you're trying to give something in bearing, bearing is clockwise degrees from north. So I've rotated clockwise all the way around, and what I found was that there was 130 degrees over there. So here's how I write my final displacement. I know that my displacement was 620 meters, right, with a bearing, so there we go, a bearing of 130. Now, sometimes you'll see bearing with or without the degree sign. I prefer to put it in there to show that people actually know what I'm saying. So it's 620 meters. There's my magnitude with a bearing of 130. Let's actually say 620 meters. Let's put them all together. So, guys, you need to be able to display this. Okay, now that wouldn't be a great answer in an exam because I want to have the symbol for displacement. Now, if you're watching very carefully last week, I said that the symbol for change in position, especially along a flat ground, was change in x. So therefore, delta x is equal to 620 meters with a bearing of 130 degrees. So that tells me how far I went and in which direction I landed up. And that is how I get to my vector. Okay, so what I'm going to do is I'm going to move straight on to the next definitions, and we're going to start to take a look at the difference between velocity and speed, because these were the next ones.
Can we just check out
Is there a
some
question?
questions? Yes.
Oh, fantastic. You guys are interacting. Good.
So Damaris Litlache is asking, can we calculate the displacement using the Pythagoras theorem?
Oh, I'm so glad that somebody asked. Okay, can we calculate the displacement using the Pythagoras method? Somebody managed to see that the triangle that I had on my screen was a right angle triangle. Now, let me just show you what I mean in terms of that. So we're going to go back to that example for a second, and I'm going to do a calculation for you. Now, I said that I would show you that sometimes doing this on a map, doing this on my page is less accurate. And I'm going to show you that 620 meters isn't exactly accurate.
Okay.
Because here we go. We had two parts of a triangle here. We had two smaller vectors. I had a movement which was 320 meters in one direction. Then I had another movement over here which was 560 meters. Now, what this mindset has managed to find out is that this makes a right angle. Very, very good. My resultant is directly from A to B. Now, we can actually find that using Pythagoras. And if you do this using a calculator, you'll find an answer which is slightly different to what we found on our diagram. In fact, let's do this together. So what I'm going to find out is what my resultant is. Now, resultant squared is going to equal 340 squared plus 560 squared. Right? And let's actually do this together and find the square root. Okay, and I've actually cheated a little bit. We did this in the break. Okay, so there we go. 340 squared plus 560 squared, and I get an answer over there. But now, please don't forget, that's still your resultant squared. I did not move that far. There's no ways I moved that far. If I moved that far, I would have gone around the earth 10 times. Not happening. Let's square root my answer. So there we go. So I square root my last answer, and there we go. 655. You can see that the answer is slightly different. So there we go. My resultant there is 655.13. So 655.13 meters. Now, once again, the bearing will still be correct, so we can say that our bearing of 130. Remember that this is displacement. So you can see that 655 is slightly different from 620 because we're working with construction. Construction is always going to be less accurate. Guys, this is way more accurate, but you need to know how to do both. So excellent, excellent question. I can see the mindset is really sharing nicely.
We have another similar question from Bongi, and she's asking, am I allowed to use trigonometry to find displacement?
Okay, yes. So trigonometry, the measurement of triangles, yes, sometimes you can use those to measure out your displacements, and that's what we've done here. We've used Pythagoras, and you can use trigonometry to find out your angles on the inside here. Now, we did it using construction. Now, you need to be able to do both. So both skills. So you either need to be able to scale it off a map or use trigonometry. That way you can be prepared in a test or an exam and figure out whichever way is possible there.
Okay.
Awesome question.
One more comment from David. He says, distance is a scalar because it has no direction, and displacement is a vector because it has a direction. I think that was a comment regarding like a question.
Oh, absolutely. I asked the mindsetters a little bit earlier on, talking about distance and displacement. Displacement is different from distance because displacement has a direction. And it's even slightly different from distance as well. Okay. Very good. I'm glad these guys are interacting.
All right. That's cool. It. That's
excellent.
Yes.
Okay, well, these guys look like they're raring to go and they're listening very nicely. So what we're going to do is we're going to jump straight to the difference between speed and velocity. Now, they are very, very closely related to each other. So here we go. The speed is the rate of change of distance. Now, you know this from maths before. If I go a certain distance in a certain time, that is my speed. How quickly I'm covering it is my speed. Now, here we go. Here's the new word. Velocity is the rate of change of displacement, or slightly different. But because velocity used displacement, it also becomes a vector itself. So let's take a look at the equations side by side and try and spot the differences. So it says that speed is distance over time, whereas velocity depends on the displacement over time. So now what I'm going to do is I'm going to use the example which we talked about earlier, and we're going to try and calculate what the speed was and what the velocity was. So I'm going to bring up a fresh map so we can scribble a little bit. Okay? And here's some information. It tells me that it took 2 minutes to get from position A, that's my starting point, to position B. Now let's just remind ourselves of some of the vectors involved here. So what happened was I went from A, I moved 340 meters in one direction, then I moved another 560 in another. That means that I moved a total distance of 900 meters. That's quite important. But yet on my map, I found that my displacement was 620 meters. Okay, that was a change in position. So what I'm going to do is I'm going to work out what my speed and what my velocity were. So let's work with the average speed first. Now, you might notice that the equation looks slightly different to how it did before. I'm using symbols instead. So capital S for speed is equal to capital D for distance over delta T. Now, anytime you see this triangle, it just means how much time it took. So delta T. That delta means the change in something. So my speed depends on how much distance there was and the change in time. Now there's a trick to this. I want to see if you guys can figure out what the trick is. I know that my distance was equal to 900 meters. That's the total distance which I traveled. But what about the time that it took? I told you that it took 2 minutes to do this. But I can't substitute 2 minutes. Remember that minutes and hours don't work very nicely. If you guys were watching last week, minutes and hours divide by 60 and all sorts of weird stuff. We need stuff that divides by 10. And there we go. The change in time over there, if I take 2 minutes and change it into seconds, I get 120 seconds. Now let's find out my total speed. Okay, so what I'm going to do is I'm going to grab my handy Casio calculator and we're going to play around with this. So my Casio calculator says a couple of things. So it says 900 divided by 120 seconds, not 1,200. Let's make sure that we don't get too carried away. What that tells me is that I was moving at an average speed of 7.5 meters per second. Okay, so there we go, 7.5 meters per second. Notice how speed doesn't have a direction. I was moving at 7.5 meters per second the whole journey, and that was my average speed. But what about the average velocity? So let's deal with the velocity over here. Now, you might notice some really strange things going on in here in terms of all these weird Greek symbols and all these new letters. Guys, just relax. Okay, the velocity is represented using V. You might notice that there's a tiny little thing on top of it. That little flat line, sometimes you see it inside a textbook. That is the average. Anytime you see this little bar sitting on the top of there, that is the average velocity. That's one of the ways that we can say that this is the average velocity. That means that the velocity could have changed during, but this is the total. So remember what I told you about the triangle? The triangle means the change. So the change in x, which is the change in position, over the change in time. So what was the change in position from position A to position B? Now I use my displacement to calculate my average velocity. So here we go. The displacement was 620 meters. The change in time is exactly the same. It still took me 2 minutes to do that. So now my meters divided by my seconds over there. And let's plop that into my calculator and let's see what comes out. So 620 divided by 120 seconds, I get 5,17 if I round that off. So 5,17 meters per second. Now, I'm not done, guys. I told you that if I use displacement, which has a direction, velocity must also become a vector itself. So I've got to write my answer here with the direction. In fact, I lose marks if I don't give vectors with directions. So I say, therefore, V is equal to 5,16 meters per second. And lucky for us, we worked out the direction a little bit earlier. So we can say bearing of 130 degrees. And there we go. We've got our final answer over there. So there's my final velocity. It's got a magnitude and it's got a direction. Now I want to run you guys through a particular problem that some of the people in my class found it very, very difficult to start talking about, in terms of talking about distance and displacement. Now you might say, okay, well, how far do you walk in a day? Now you might say, okay, well, you know, I kind of walk to school, and then at school I walk around maybe 1 kilometer, then I walk home. I walk around about 9 kilometers in a day. I want you to start thinking about what this means for distance versus displacement. Now, what you've described is many small pieces put together, and I say, okay, well, up to 7 o'clock, I walk to school. Let's say I walk 1 kilometer to school. I walk about 2 kilometers at school, and then maybe 1 kilometer back. I've walked a total of 4 kilometers. That is my distance. Okay, now you've got to be aware of the following. Displacement is something different altogether. Now, my science students, especially my grade 10 class last year, were very despondent about this. What is your displacement over a 24-hour period? And they might say, okay, well, I've got to start calculating this and this. And guys, it's actually really easy. What you've got to do is look at where you are, where you began, where you are, where you finish. That is your displacement. Now, if you take your displacement from 6 o'clock in the morning to 6 o'clock in the morning, it's almost certain that your displacement is 0. You might say that's impossible, Philip. I move around all day, and I move to school, and I move around at school. I move to this class, I move to so-and-so's class, and then I come home and you say, guys, displacement is only measuring how far you are from your beginning point. If you end at the same place, your displacement is 0. So if I go to sleep, right, 6 o'clock, I wake up. That's where I start. I start my day at 6 o'clock, I stand at my bed and I say, right, I'm going to go move some distance around. And then I get back to my bed, a little bit late at night, I've been marking some papers and I get back in my bed. All of a sudden, I'm back where I started. My displacement has become 0. I've actually achieved nothing, and sometimes it feels like that. I've gone around, I've run around like a mad thing, I've achieved absolutely nothing. My displacement is my end change in position. It depends on when you're measuring it. For a 24-hour period, great, there's no displacement. For a 12-hour period, halfway through the day, I'll be very far away from home. And that means that I'm far away from my starting position. So you always measure from your starting position. I just wanted to draw something which illustrated the point very nicely. If you walk a very, very skew path and you end up at a different position over here, the best way to measure your displacement is to take a nice straight ruler, start from your starting position, and measure it directly at the end. It does not take into account the path. Use your displacement to calculate velocity, your distance for speed. I think that's all we have time for. I think we've got another lesson next week, though, so don't be despondent.
Mindset is don't be despondent, like Phil said. So we'll see you next week. Same time, same place. Thank you so much for tuning in and for being great on the page, for interacting. Shout out to Aphiwe Twale, Podiuso Bongiwe, Aphiwe Mtembu, and yes, those guys. Thank you so much, guys, for tuning in, and until next time, we'll see you then. Goodbye from us.